Hi ladies, we're going to go through the more challenging questions for 8G in this video. So 8G is looking at independent events. So remember, independent events, so one event does not affect the probability of another. So think of flipping a coin. So getting a heads one time doesn't, you flip it again, it doesn't make any difference to the probability. Rolling a dice doesn't make any difference. If you're doing multi-stage experiments like selecting some counters from a bag, as long as you put them back, then the probability doesn't change. But if you don't, so it's without replacement, then those events are not independent. So independent just means the probability of one thing happening is not affected by the probability of something else happening. Okay, so let's have a look at question 8. So use this diagram to help decide if this statement is true or false. If two events, I'm just going to get my pen. If two events A and B are mutually exclusive, then they are also independent. Okay, so we know that for events to be independent, it's a terrible spelling of the word independent, the probability of A has to equal the probability of A given B. So let's look at the probability of A for this one. So the probability of A for this is 2 over, what do we got? 6, 9. So 2 over 9. And conditional probability formula is the N, so the number of A and B over the probability, the number of B. You can do the probabilities, but you get the same answer. So 2 over 9 simplifies to 1/3. A and B, there's no intersection here, so it's just 0. And B is 4. So does 1/3 equal 0? No. So they're not independent. And I think this question here is asking if two events A and B are mutually exclusive, then they are also independent. No, that is not true. Okay, so don't get independent events mixed up with mutually exclusive events. So independent just means one event doesn't affect the probability of another, whereas mutually exclusive just means they have nothing in common. So independent events can have something in common, but they can also be independent of each other. All right, let's have a look at question 9. So consider the events A and B with the number of elements contained in each event given in the Venn diagrams below. In each case, find the value of X so that the events A and B are independent, i.e. probability of A is equal to the probability of A and B. So that's just your to check that they're independent. Okay, so we want the probability, I'm just going to rewrite it here, and probability of A and the probability of A given B. So the probability of A is 3 over our total. So we've got 3, 6, and an X. So 6 plus X. Okay, we don't know what X is. And then the probability of A given B, so their intersection over the probability of B, which is 4. And then we just got to work out what X is equal to. So here we've just got an algebraic equation. So you could use solve on your calculator if you wanted to use your calculator, but we can easily solve this by hand. Okay, I'm going to, when the unknown's on the bottom, I just like to flip. So let's do 6 plus X over 3. 1 over 4 becomes 4 over 1, or just 4. All right, multiply both sides by 3. So that cancels out. We've got X plus 6. Sorry, let's just rub that out. I knew that was going to pop up. Go away. 6 plus X, equals 4 times 3 is 12. And then subtract 6 from both sides. So that goes, X is equal to 6. And you can always check your answer. So 3 over 6 plus X, so 3 over 12, is that equal to a quarter? Yes, it is. So x must be equal to 6. All right, let's have a look at question B. So the probability of A must equal the probability of A given B. So the probability of A is 12 over 14 plus x. Probability of A given B, so we've got 1 over 3. Like we did before, you can just flip your fractions. Okay, so now my unknown is on the numerator, which makes things a little bit easier. Multiply both sides by 12. Okay, I had to delete a bit because I made a mistake. There we go. 14 plus x equals 3 times 12, which is 36. Subtract 14 from both sides. So that goes, and we're left with now x equals, oh, I didn't write 14, I wrote 4, but it is 14, so 22. Let me just put that 1 back on. Okay, so we can just check our answer by substitution. So put that 22 into here. So we're going to have 14 plus 22, which is 36. 12 divided by 36 is equal to a third. So awesome. Okay, last one. Question C. So this time we've got probability of A equals the probability of A and B. So the probability of A is x plus 1 over, we've got x plus 1, 3, 7. And then we've got the probability of A given B, so 1 over 3. All right, again, I'm going to flip it just because I want to deal with the number 3 and not the number 1. So, sorry, not a third. So I've just flipped my fractions. Now I'm going to multiply both sides by x plus 1. Let me just get my pen. So they cancel out. And you're probably thinking, am I complicating things? Might seem that way, but we need to really get rid of that division. So 3 times x is 3x, 3 times 1 is 3. And now we'll bring everything over to the same side. So I'm going to subtract x from here. So I'm left with 7 equals 3x minus x is 2x plus 3. And I'm going to subtract 3 from both sides. So now we've got 7 minus 3, which is 4, equals 2x. Divide both sides by 2. And x is equal to 2. So a little bit harder for that one. But let's just check our answer. Okay, so 2 plus 1 is 3. 2 plus 7 is 9. So 3 over 9 is equal to a third, which is good. And I think that's our last question. Bye, girls.